So let's go with the almost lost talk of the conference. We have on stage Dave DeLong. He has said that for many years he wanted to come to NS Spain, but actually what NS Spain wanted is Dave DeLong to come. And as Paul Hudson showed before, all the conferences have an architecture talk. Enjoy.
Thank you, Luis. So my name is Dave DeLong. If you haven't heard of me, I worked at Apple for a while. Now I work at Snap. And generally, I like to think about interesting problems. Today, we're going to talk about the MVC pattern. MVC tends to get kind of a bad reputation in the developer community. Who can shout out and tell me what's the problem with MVC? Massive view controller. So if you're unfamiliar with this problem, which, awesome, massive view controller is the idea that we start building our UI view controllers and we just put things in them, and more things in them, and more things in them. And unless we're careful, we'll end up with a view controller that's a couple thousand lines long. Or you join a new team or take over a new project and you start looking through their code and you see, wow, they've got these view controllers that are like 2, 5, 10,000 lines long. And you get a bug assigned to you that's like, there's this one little animation that's not working right. And you've got to dig through 10,000 lines of code to figure out where this timing with an animation and callbacks is going wrong. And you just think, I don't want to live on this planet anymore. This is terrible. No one wants to do this. I'm going to let you in on a secret. Massive view controller is our fault. There is nothing in MVC that says you have to end up with a massive view controller. Because when we start a project, we don't think, boy, I want to break encapsulation, practice Brad principles, make things really tightly coupled. Like, no one says this. And yet this is how we end up. So why do we make this mistake? Well, in a way, it can kind of be Apple's fault. When we get sample code from Apple, they often put things in the view controllers that in a real app, you probably don't want to put there. And if you think about it from the point of view of sample code, it can kind of make sense. The sample code has a goal, and that goal is not necessarily to show you good app architecture, but to show you how to use a particular API. But we take this sample code and we just kind of start using it, and we don't really fix the problems that it started with. Then there are times where we're going along and we're working on an app, and we're just not really sure what to do, and so we just kind of drop stuff into the view controller because we can't think of a better place. Because when you're going out and you're writing your own custom app, you're not going to find a tutorial online about how to build Dave's custom app, right? So you maybe kind of get a little lost and throw up your hands and like, well, I'll put it in the view controller and deal with it later. Then, of course, there are all the external constraints we face. Maybe we're on a tight schedule. Maybe we are lacking the experience. Maybe we don't have the budget in time or other team members to help us out with this. And so we just kind of like are throwing things in because we've got these constraints. Now, when we come across these sorts of massive view controllers, our gut reaction is to feel really gross. And we want to take the whole thing and throw it away in the trash. There's a quote by a famous philosopher who's actually Spanish, named George Santayana. And he says, when experience is not retained, infancy is perpetual. Those who cannot remember the past are condemned to repeat it. When we throw away the code of what we had before, when we do file new project and are just giving up on fixing what we have, we are not retaining experience. We are not keeping around the lessons learned from previous mistakes. And we remain in infancy. And we end up condemned to make a lot of the same mistakes that we saw our predecessors make. So instead of throwing away our code, instead of deciding, well, I'm just going to go use Viper instead of MVC, let's instead refactor this pattern. Let's refactor MVC so that we can arrive at something better. And we start with refactoring by noticing things. So let's make some observations. The first observation I want to make is that MVC is not actually a design pattern. Now, this is kind of a little unusual, so let's think about it. What does MVC say? It says that we should separate our data from how it's displayed, and all of that is separated from the logic that manipulates the two. This is a philosophy. It's not a strict ordering of here's where you break things up. It's more of a mentality, a way of thinking about a problem, which is that storage is distinct from networking, which is distinct from parsing, which is distinct from your business logic, which is distinct from rendering and your view hierarchy and your routing and everything else that you might want to put into your app. They're all separate little pieces. This is what MVC is trying to say. We separate all of these problems. And so as we separate, we ask ourselves, who should care about this information? Who really needs to know that I'm going to be using an implementation of drawrect or a CA layer? Does the model need to know? Of course not. Well, I sure hope not. Who really needs to know? And if we ask, we realize that it's only this one little piece that needs to know, then we can hide that information. We can practice good information hiding principles. So this is point number one. MVC isn't really a pattern. But the patterns that we do use are not panacea. They're not universal solutions to the problems. They are tools. Now, as we're building apps, we all face a lot of really similar problems, right? We all need to handle state restoration. We need to handle accessibility. We need to handle, some sort of analytics gathering. We need to handle deep linking, all of these things. And so we all face similar problems. And similar problems end up leading to similar solutions. And as we recognize commonalities in these solutions, we kind of package them up and say, well, this is a pattern. But the converse is also true, that when we face different problems, we come up with different solutions and end up with different patterns. As an example of this, the way that we build iOS apps, whether it's a banking app or whether it's, some inventory app or a news app, these are all vastly different apps than you might want to build if you're building a game. And the patterns that you use when building a game tend to be extremely different than the patterns you use when building an app. Now, as we develop in our professional career, we like to learn about new patterns. There's Viper, and there's this Discover pattern, and MVVM, and React is the new hotness and everything. And so as good developers, we learn patterns. But I would suggest to you that if you want to be a great developer, don't learn the patterns. Well, learn the patterns. But in addition to learning the patterns, learn the problems those patterns were trying to solve. Learn what was it that led people to think that functional reactive programming would be a good solution. What was the problem they were trying to solve? What was the problem that Viper is trying to solve? What is the problem that MVVM is trying to solve? And as you learn the problems, then when you face similar problems in your own app, you are better equipped to pick the right tool for the job. And maybe React is the right pattern. Maybe FRP is the right pattern. It depends not on the pattern, but the problem. Observation number 3. Naming things is hard. We know this is like one of the hardest problems in computer science. That naming things is difficult. Like, if you ever taken a look at the Swift Evolution forums and like how much time is spent deciding what we're going to call something, this is a hard problem. And one of the things I want to point out with naming is that just because it has the word controller in the name doesn't mean it's actually a controller. Okay? Now think about this in other situations. With the MVVM pattern, we have this object that we call a view model, right? Well, it's kind of a model, but it's not a view, right? It doesn't display anything, and yet it has view in the name, so it makes sense that just because there's view in the name, it's not really a view. So we can extend this and say, well, just because it has controller in the name, it's not really a controller. And so with this understanding, I want to put forward an assertion. And before you break out all your pitchforks, just stop, consider this. UI view controller is not a controller. Even though it has controller in its name, it's not actually a controller. If you think about it, what does UI view controller do? It loads a view, shows a view, it reacts to the view, it restores the view, saves the view. It only does view things. So maybe it's really a view, right? Maybe it's really something that we should consider as part of the UI layer of our app, and not necessarily the logic layer. So we're going to stew on this, and we're definitely going to come back to this. Observation number 4, views don't fill the screen. This seems pretty obvious, right? Your entire app is not a single UI view. I really hope not. If not, let's have a conversation afterwards. And yet we have this mentality that when we're looking at a screen full of information in our app, that's a single UI view controller. But it doesn't have to be so. There is nothing in UIKit that says a UI view controller has to have the same bounds as your screen. A UI view controller can be 1 point high. It could literally just be a horizontal line. It could be invisible if it's a container view controller. It could be, a view controller that only shows a single image. There is nothing that says a view controller has to be the size of the screen. So we've made these observations. What are we going to do about them? First off, let's start decomposing our UI view controllers. If you're unfamiliar with the term of decomposition, kind of think like a zombie. A zombie is decomposing, right? So it is breaking itself apart into little bits, right? So we want to decompose our code and break it apart into little bits. And I would argue that the ability to decompose problems, to break them apart into smaller and smaller problems, is the number one thing that determines how effective you are as a programmer. In my experience, all of the really great programmers are able to break apart problems well and build together solutions. And all of the developers who struggle, who don't seem to quite get it, they struggle with this. They struggle to identify where does this problem break apart into smaller problems. So let's break apart our view controllers. Instead of having a single screen that is a single view controller, we can make this screen be many view controllers. As some examples, I'm, of course, like most developers, have my own set of frameworks that I've built up over time. And I've come up with a few view controllers. And I'm going to list some possibilities here and some other ones later. But what if we only had a view controller that just shows an image? This is totally fine. Even if it's a 32 by 32 point image, that's totally fine. What if we had a view controller that only shows a horizontal line? This is also fine. What if we had a view controller that was a cell inside a table view or a collection view? This is also fine. There is no rule that says you can't put view controllers in these places. In fact, I would argue that these are some of, in my experience, some of the best places to use view controllers. If I have a view controller that only shows an image, then I don't have to deal with this idea of a UI image view that knows how to hit the network in order to download an image from a URL I gave it, right? An UI image view should really just show an image. So instead, I can have an image view controller, maybe give it some sort of image future or image promise or something, and then when that image actually becomes available asynchronously, it's just going to take it out, stick it in its image view. And suddenly, I have lazy loading images everywhere in my app. So let's decompose our view controllers. Next, with these decomposed view controllers, with these view controllers that do single isolated little things, we can now compose our UI. And we're going to build our UI by composing view controllers. Just like you compose a piece of music by putting together lots of notes, our view controllers become the notes of our application, and we can compose them together to make our app. And we do this using an API called addChild, or in Objective-C, it's addChild view controller. And I want to point out here, this was added in iOS 5. None of you are not supporting iOS 5, so you have no excuse to not use this. So this is the fundamental way we're going to be building up our UIs, is with child view controllers. Next, we want to build view controllers that are reusable. And I want to point out here that I'm not talking about reusability in the same sense that table view cells and collection view cells are reusable. I'm talking about a reusability from the point of view of, I want to be able to use this view controller in multiple places. Whenever we need to show text on the screen, we don't run off and rewrite UI label. Like, that would just be dumb. So why is it that whenever we need a new screen in our app, we feel that we have to go off and rewrite UI view controller? I would say, as we're building our view controllers, build them in such a way that we expect to use them in many places. And here I want to give some examples of ones that I've found extremely useful. The first one I call a container view controller. And this is just a view controller of any size that shows another view controller. Now, this sounds kind of dumb at first, but the neat thing about this is that I can change at runtime, just by calling, set content on it, what the view controller inside of it is. And when I call set content, it's just going to do a simple crossfade, a dissolve animation from the old one to the new one. And once I've got this, then suddenly the possibilities multiply. The container view controller is always the root view controller of my apps. And I can then decide, well, at app startup, has the user agreed to the consent agreement? If they have not, set that as the content. But once they've agreed, just set a new view controller, which is the app's main navigation controller. And container view controller is just going to do this nice little crossfade and switch from the consent screen to the navigation screen. Or maybe I need to have an activity indicator, a spinner, showing some sort of ongoing progress. So I have a container view controller, and inside that I put an activity view controller. And once the activity has finished, I just set an image view controller, for example. And now suddenly I've got lazy loading of image views and spinners indicating, and it's all just cross-fading nicely. Very handy. Next, I use a stack view controller. So just like UI stack view will manage a stack of UI views, a stack view controller manages a stack of UI view controllers. And using a stack view controller, it makes it really easy to build up these sorts of detail informational form screens where the top view controller might be some sort of profile header view controller, and then I'll have a separator line view controller, and then maybe a view controller that's just showing a title label and some detail text, and then another separator view controller, and so on. Now, by itself, a stack view controller can sometimes grow beyond the screen. So if I decide, well, in this particular case, I'm going to need it to scroll, I'll throw it inside a scrolling content view controller. And this, again, is just another view controller that if the height of its content is greater than the height of the scrolling content view controller, it puts it inside a UI scroll view. And now suddenly I can make anything in my app scrollable if it gets too long. I don't have to worry about, oh, well, I've got to use a table view controller here because, it's got the scroll view built in. Like, no, it's just, I need it to scroll. I put it in a thing that scrolls. And one of the things about building view controllers in this way is that you end up with accidental consistency. If you're expecting to reuse view controllers, then you're going to find, well, I'm going to have the same behavior everywhere because it's all just using the same fundamental building blocks. So let's reuse our view controllers. Number 4, forget about UI view. If you follow this practice of building things up using UI view controllers, you will find that you rarely subclass UI view anymore. There are really only 1 or 2 times you need to do it. You'll find that you can just do everything else by composing together view controllers. Now, when we think about it, UI view does 2 main things. It renders things, and it lets us interact with things. And I want to tell you a secret about UIKit. Everything that you see in UIKit is rendered with either a UI label or a UI image view. Everything. Whether it's something like UI progress view with its bar filling up the screen, that's really just an empty UI view, some image views to draw like the caps in the middle of the track, and some other image views for the caps in the middle of the progress bar. UI text field, which seems like this insanely complicated thing, and it kind of is, but it's drawn, again, just with an image view for the border, and if you're not editing it, a label in the middle for the text. Everything is pretty much drawn with label or image view. I can't think of exceptions to this. Interaction, if we need custom interaction, we can use gesture recognizers, right? So if we need custom UI, we can just compose it together out of these fundamental parts of labels to show text and image views to show pretty much everything else. And so when we find ourselves needing a complex control, consider making it a view controller instead. If the rest of your code is set up to handle this, make it a view controller. You will never need to override drawRect. In fact, none of you should be overriding drawRect now anyway. Should be building your UI by piecing together smaller parts. So let's put this into practice. As we get down this road, we'll realize a couple of things. So a couple of, not quite laws, but really good suggestions. First off, we realize that our UI is there are 2 main flavors of UI. And that is a UI element will either show data directly or farm out that responsibility to its children. So like I talked about, all of the UIKit views either show data directly, which is UI label and UI image view, or they farm it out to their children, which, if you go deep enough, end up being UI labels or UI image views. So everything else composes those 2. As you get into this with your view controllers, you'll find the same. You'll find that you have 2 flavors of view controllers. You have view controllers that only show data, and this would be data of like the data for like what color is my separator line, or what is the UI image to put in this view, or what is the string to put in this label. Or you will end up with view controllers that get in their view model, if that's how you go, and break it all apart and give the individual pieces to other child view controllers. Now, there are some cases where you end up with a view controller that does both, where it both manages children and puts data into its views. Some examples off the top of my head would be UI navigation controller, right? Because it manages the side-to-side transition of its children, but it also owns the UI navigation bar. Same thing with UI tab bar controller. But then you have other view controllers, like UI page view controller, where you give it view controllers, and that's pretty much about it. It just lets you slide between them. So your view controllers will either show data, or they will show children as a general rule. Next, as you're wondering, where do I break things apart? I want you to think about generic functions. So if we consider some UI kit elements, whether it's UI navigation controller or even UI table view, let's think about what these take as input and what they get as output. So with a navigation controller, its input is going to be UI view controllers, right? We say push view controller, pop view controller, present view controller. So the input type is UI view controller. With UI table view, we give them NS index paths, right? The input type is index path. Select row at index path, or number of items in section, or number of sections and number of items in section allow us to build index paths. And so our input there is index paths. This means that our output types, the types that we get given as delegate callbacks or as action parameters, need to be the same type. So with a UI navigation controller, the delegate methods are always did show view controller, did present view controller, will show view controller. It's always in terms of the same input type. And the same thing with table view. You don't get told, hey, we selected this item. You get told, we selected this index path. Because index path was the data we gave it, so index path is the data, it gives it back. Let's apply the same principle to building our view controllers. So let's imagine that we have a list view controller. So this is going to have some UI, and we're going to give it some array of T. And this T is going to be some sort of item API, who knows. And this array of T translates into items in this list. This means, since we gave these T objects, these T values to our list view controller, that all of the information back out of it needs to be in terms of T. So if it wants us to ask if we're allowed to select something, it's going to ask, am I allowed to select this T value? Doesn't give me an index path, because that's not what I gave it. So, do I select this T value? Or, hey, I'm about to show this T value. Or maybe, like, the list view controller knows enough to understand some contextual actions and say, hey, the user's about to perform this action, but it's an action on a T value. So T goes in, T comes out. So this is how we're going to think about view controllers. We're going to think of them almost like functions. Functions that take some sort of T input and give us that same kind of T output. Or in some rare cases, functions that take some T input and don't do anything. An image view controller would be an example of this. Like, we don't need to interact with an image view controller, so there's no real output for it. It's a T to void function. So the rule is, what goes in must come out. So if you're dealing with maybe an edit profile screen, you've got the profile information, and you decide, I want the user to edit their profile. So they tap the edit profile button, and you bring up a new view controller that is the profile editor view controller, and you know that since I initialized it by giving it a profile object, then that means the API should be a delegate callback or a closure callback or something that gives me a new profile object. It would kind of be a violation of this principle for the editor screen to just save it directly to the database. And if we think about a profile editor this way, we can imagine how having these more explicit input and output entry points allows things to be far more testable. If our profile editor view controller is just going to save things directly to the database, that's a hard thing to unit test. But if our profile editor instead just gives us a new profile back, then we can just say, edit this thing, let the UI test run, get a thing back, and then just compare the two, and we're done. And then we can test the profile saving code independently. So our input can be anything. Any sort of way to provide information to a view controller. It can be a data source API, like UI table view. It can be parameters that you pass into an initializer function. Maybe you're passing in some sort of signal or observable if you're using a more FRP style one-way data flow. Maybe you're setting properties on it. These are all the ways in which we get data into view controllers. Then getting data out happens via delegate protocols or callbacks, or maybe again, there's some sort of signal or observable. These are the ways we get input and output. And I want to point out here that this is kind of how encapsulation works. And I want to put forward the hypothesis that violating this idea of a T to T function is a way of violating encapsulation. And with that in mind, I want to talk about storyboards. When you start using storyboards, you think, this is so great. I can see my whole app right here. I've got these lines that just show everything, and it's great. And then you start thinking about it, and you realize segues are a problem with a capital P. Because navigation, the act of moving from one screen to another, is a violation of this T to T constraint that we just learned about. It is not the responsibility of some inventory list to know what comes next. The inventory list only knows how to list inventory, right? If you're writing a banking app and I want to look at my recent transactions on my credit card, I'm going to have some sort of screen with a list of recent transactions. That screen only knows about listing recent transactions. Why should it know whether this is in the context of looking at my bank account, looking at my child's bank account, looking at mortgage payments? Like, it should not know. Your UI button doesn't know that it's going to present an alert. So your UI view controller should not know what comes next in the flow. Segues additionally break reusability, because you've kind of got this hard-coded thing of like, well, I've got a segue with this explicit hard-coded identifier, which I then have to hard-code into my code, and now I can't really use that view controller in any other spot because I've got this big whole huge prepare for segue method where I'm kind of switching over, well, it could be this scenario or that scenario or this scenario or that scenario. And this is a major problem for reusability. And this is partly because prepare for segue is, in my opinion, called on the wrong object. But unfortunately, there's no good way to fix this that I've come up with, so I just don't use segues. And I would argue that as you're getting more into decomposing your UI with view controllers, that you will probably end up not using segues either. So what should you use instead? Well, I think you should use zibs. If you're unfamiliar with Apple history, way back in the day, we started with these things called nibs. And nibs was kind of a joke because when you're talking about cocoa, like the actual food product cocoa, there is a part of the output process of making chocolate that you end up with these things called nibs. It's kind of like a broken apart piece of some of the cocoa byproduct. And so during the next step days, as they were building what eventually became AppKit, they thought, well, could be kind of funny, cocoa nib, ha ha ha. And so they called them next step interface builder files, so NIB or nibs. And then people realized, well, these are really cool, but they really don't play well with source control. And so they were like, yeah, that's true. Let's just make them XML, because that you can diff in a source editor or in a diffing tool. And then we'll call them ZIBs, because we're so clever. So we have ZIBs, XML interface builder files. And if you go and you look at your storyboards in Finder and you do like, show package contents, or you crack it open in a text editor or whatever, you'll see it's a whole bunch of XML, and that it's made of a whole bunch of ZIBs just kind of smushed together. And when you build it, it builds into nibs, because nibs is now like the binary format for your UI. But ZIBs have this one-to-one relationship between a view controller. This is where we get the initializer init with nib named bundle, right? We pass in the name of the nib, which is the compiled ZIB, and boy, this is not confusing at all. You pass in the name of your UI file, and it's going to load it, and then you get your view-did-load callback. This is really nice when you're dealing with decomposed view controllers, because you can build your single UI view controller. Maybe it's like your image view or your activity indicator. Maybe it's a more complex control. And then you have a single file where you're just dealing with the UI for that one little piece. And maybe the UI is literally nothing more than an empty UI view that you set the background color on. Maybe it's a UI view that you just drop in a UI activity indicator. Or maybe it's more complex where you've actually got a lot of stuff moving around and you're going to put in images. The point is that you have a one-to-one correspondence between your view controller and your UI. This makes it really easy to know, well, this part of my UI doesn't look right. I know exactly where to look, because it's in this one view controller, which has this one file, if I've decided to use a ZIB to write the UI, or maybe I've done the UI programmatically. It's small, it's self-contained, and you don't have merge conflicts. Because how often do you have multiple programmers saying, well, I need to fix the image view controller at the same time? It just doesn't happen. We get really scared of interface builder and storyboards and ZIBs because we put this problem on ourselves. Like we do with massive view controller, we have massive ZIBs and massive storyboards. This is a problem of our own making. It does not have to be this way. But the nice thing about ZIBs is we still have everything that we're used to. We get our outlets, which is nice, because then we can just hook things up and don't have to worry with auto layout code and all that gross stuff. But the neat thing is that now you can get custom initializers. You can just call init with foo on your custom UI view controller, and it'll just work, right? Because you're specifying the nib there. You've got a place where you can set your properties. You don't have to deal with so many optional properties anymore. It's really, really nice. So going back to this idea of segues, if we've got this master list, and we want to show a detail view, we think, well, something happens inside the master list, and I'm just going to call show detail view controller, or I'm going to call perform segue with identifier. Do not do this, please, please. This violates encapsulation. The master list should not know what comes next. So what does this look like instead? Well, when we select something in our master list, it's going to tell its parent. Whether this is, maybe you've built your app so that the parent is its parent view controller. Maybe it's some sort of hierarchy outside of that and you call them coordinators. I don't know. This is not what I'm getting into. But when you tap something on the master list, it's just going to send a message up to the coordinator saying, the user tapped this item. And it's the same sort of item you gave me. So maybe it's a list of bank transactions. So the user tapped this transaction. Or maybe I'm looking at a profile. The user wants to perform this action with the profile. That's what it's telling it. And then this parent object, whether it's a coordinator or a manager or whatever like really generic term you want to give it, it decides what that means. What does it mean to select a transaction in the list? Maybe it means I want to see the detail. Or maybe it means this is the one I want to dispute with my bank. Or maybe it means this is the one I don't know, what do you do with bank transactions? This is the one I want to do something else with. Maybe this is just the one I want to select as like part of a multi-list selection thing. It doesn't know. And so it's not the job of the master list to know the semantics of what this action means, because it only lists items. Finally, we can adopt this piecemeal. Unlike other architectures that kind of have this all-imposing, self-aggrandizing view of themselves of like, this is the one true pattern you have to use, there is nothing about what I've been talking about that says you have to go rewrite your app. In fact, I do not want you to rewrite your app. I do not want you to remain in that infancy. I want you to learn and grow and not be condemned to repeat your mistakes. We can refactor our apps. This pattern is an excellent one for adopting piecemeal. If you're working on just the profile editor for your app, you can start using smaller view controllers. You can start breaking up your UI into smaller view controllers for just that one part of your app. And the rest of your app doesn't have to know. And then as you get further along, you can start doing this more and more, and you can kind of just like slowly make your app beautiful. So if you adopt this, you will find you end up with tiny view controllers. I took a look at some of my apps as I was preparing for this talk. I have an app with hundreds of files, and only 24 files were longer than 200 lines of code. And of those 24 files, 18 of them were either unit tests or from a third-party dependency. So in my entire app, I only had 6 files of any kind that were longer than 200 lines of code. How nice is it to work on a view controller that's like 150 lines of code? You don't have to think hard about what's going on. You don't have to be digging around amongst 10,000 lines trying to understand what's going on. You know, data comes in here, kind of processed and shown here, and here's some action methods. And that's it. You will find, like I mentioned, that you rarely subclass UI view because you're just kind of building things out of your other building blocks. And you will find that you end up with these extremely reusable view controllers, whether it's the separator line view controller or the image view controller or the container or stack or scrolling content view controllers like I mentioned. As you write your code, you'll find you get a better idea of where the lines are when you deal with separation of concern. Because you have a view controller that all it does is it shows other view controllers. Or all it does is it just takes this data and puts it into labels. Or all it does is it's just going to wait for this image feature to fulfill so it can put the image into an image view. Each piece becomes so small, like the decomposing parts of a zombie, that they're easy to deal with individually. And you finally end up with happy programmers. Right? You're not faced with this 10,000 line monstrosity. You're not wondering, like, should I just quit my job and go somewhere else where I don't have to deal with this? Instead, you end up with working with code that is a pleasure to work on and that you find incredibly fulfilling. Thank you very much.